Okay, in this case we have both linear and quadratic factors, and I know you're looking at the x squared and you're saying that's not linear, it's quadratic, but this is a repeated linear factor. It's x times x, and this is your irreducibly quadratic factor, x squared plus 3. We don't have to factor because it's already been done for us, so we're ready to go ahead and start our partial fraction decomposition. I'm going to go ahead and write 2x cubed minus 5x squared plus 6x minus 3 all over the x squared times x squared plus 3. And we're going to say that is, now this is a repeated linear factor, so I have to go a over the x plus b over x squared. And then this is our quadratic. Now if it's quadratic, what you're going to do is you're going to take whatever letters come next, in this case c and d, and you'll write cx plus d all over the x squared plus 3. If the next letter in the alphabet happened to be G, you do gx plus h. If it was F there, you do G plus h. I might have gotten my alphabet wrong here. In any case, it's always, if it's quadratic, you're going to go a constant times x plus another constant, whatever's coming first in the alphabet. I need to go back and relearn those. Here we go. So we're going to multiply by our least common denominator, which is always whatever this is here. So times x squared plus 3. Distribute way over here. The denominator and what you're distributing will reduce. You'll be left with the 2x cubed minus 5x squared plus 6x minus 3 equals, distribute to the a term. One of the x's will reduce. You'll be left with a times x squared plus 3. Distribute to your b term. Both the x squareds will reduce, so we'll be left with b times x squared plus 3. And then distribute to the cx plus d. Write that in parentheses. And the x squared is left over. Now what we're going to do, we're going to pick convenient values for x. And really, I only see one. This never equals 0. So the only convenient value we have for x is x equals 0. So we write x equals 0. Plugging it in here, 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 we're just going to have minus 3, negative 3 on the left-hand side, equals a times 0 times 3, which we know will be 0, plus b times 0 squared plus 3, which is just 3, plus, now in this case you also have to plug 0 in here, so c times 0 is 0, and we're just left with d times 0 squared, and it does not end up mattering because that's 0 anyway. And so we're left with negative 3, gone, equals 3b, and so b is negative 1. Now we're kind of in a bit of a pickle because we have no other convenient values for x. So what we're going to do is we're going to substitute our negative 1, and then we're going to do a little algebraic manipulation with the rest. So we'll rewrite. We'll rewrite it. Let me make this just a little bit smaller. No, I want more of that. There we go. We're going to rewrite it as 2x cubed minus 5x squared plus 6x minus 3 is, I'm going to distribute my ax to the x squared plus 3. We'll be left with ax cubed plus 3 times ax. Now what I'm going to do is, I remember that b is negative 1, so this becomes negative x squared minus 3. And then I'm going to go ahead and substitute my x squared, or excuse me, not substitute, but distribute my x squared, get plus cx cubed plus dx squared. Now I'm just going to do some rearranging of my terms here. I'm going to group my like terms. and do a little factoring. So we have 2x cubed minus 5x squared plus 6x minus 3 is, we have ax cubed plus cx cubed. So I know that's really a plus c x cubed. We have quadratic here, quadratic there. So that's really plus d minus 1 x squared. I just factored an x squared out of these two terms. Then we have a linear term right here, plus 3 times ax. And then we have our constant minus 3. Now, in order for the right side to be the left side, these coefficients, a plus c, d minus 1, and 3a, have to be the same coefficients over here of 2, negative 5, and 6. So the first one I'm looking at is just 3a times x. In order for these two terms here and here to be the same, 3 times a must equal the 6. And so therefore a is 2. And we're very happy with that, because that means I can put a 2 here, and I can put a 2 right there. So we'll do that. 2x cubed minus 5x squared plus 6x minus 3 is 2 plus c times x cubed plus d minus 1 x squared plus 6x minus 3. I also see that d minus 1 from the x squared must be negative 5. We like that a lot. D minus 1 equals negative 5, so d must be negative 4. And also, 2 plus c must equal 2. And so c then is 0. And so I'll take all of these numbers, negative 4, 0, 2, and negative 1, and I'll plug them into these numbers up there. And we're going to do that on the next page. So I have a little bit more room. So the integral of 2x cubed minus 5x squared plus 6x minus 3 all over x squared times x squared plus 3 dx can be rewritten as the integral of, now the a over x, a we found to be 2, plus b over x squared, b was negative 1, plus cx plus d, c was 0, and d was negative 4, all over x squared plus 3 dx. And these are much simpler to do. Splitting the integral up, I'm going to pull my 2 out of 1 over x. Pull out the negative 1. And this is going to be x to the negative 2nd dx. Then pull out the negative 4. And we'll have 1 over x squared plus 3 dx, which here I'm recognizing to be arctangent. So we have twice the natural log of x, add 1 and divide, plus 1 over x minus 4 over the square root of 3 times the arctangent of x over the square root of 3, and then we have plus c.